Hello everyone, good morning to all of you. Myself Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today I am going to discuss about the solutions of question bank from Module 2. In this module, I want to discuss Part A. In Part A, problem solving and critical thinking questions. I want to discuss about the topic in Part A, problem solving and critical thinking questions. First of all, in this lecture, I want to suggest two references of textbooks related with this subject, differential equation and vector calculus. There are two most important references of textbooks which are given as below. So first reference of textbook is, the name of the authors are N.P. Wali and Dr. Manish Goyal. Publications Lakshmi Publication Private Limited. Second one is, the name of the authors are H.K. Das and Dr. Rama Verma. Publications S. Chand and Company Private Limited. So you are requested to study of these following books thoroughly and prepare all contents which are given in the syllabus. Now I am going to discuss the problem which is based on method of variation of parameters. So first of all, I want to discuss about the method. What is method of variation of parameter? So I want to prove R formulae which are related with the method of variation of parameter. How we can solve a differential equation of second order or third order or higher order with constant coefficient with the help of method of variation parameter. So first of all, I want to discuss about the procedure and I want to solve general equation. Here I am taking second order differential equation with constant coefficient and I want to solve general equation completely with the method of variation of parameter. How we can apply in a general linear second order differential equation with constant coefficient with the help of method of variation parameter. So first of all, I want to discuss method in detail and then I will solve the problem based on method of variation parameter. So today in this lecture, my topic is about the method of variation of parameter. How we can define method of variation parameter, how we can apply in a question method of variation of parameter. So my topic in detail today in this lecture, I want to discuss about the method of variation of parameters. This is most important method which is applied in a differential equation of second order with variable coefficient and differential equation of higher order with constant coefficient. In both equations, we can apply this method. So this method is very and most important method because all type of differential equation of higher order with constant coefficient and differential equation of only and only second order with variable coefficient, we can solve with the help of this method of variation parameter. So let us start to prove a method of variation parameter. In this lecture, I am giving proof of method of variation of parameter. So here question 1, by using method of variation of parameters, solve. Here equation is given A. A is any number here or A may be variable. But in this question, A, B, C are constant. A d2 by dx2 plus B dy dx plus Cy equal to x. X is some function of x. Now, this is general equation. This is not the problem. This is general equation. A, B, C are alphabets, which are number, and x is the some function of x. In this equation, there is only two variables, x and y. X and y only two variables. Y is dependent and x is independent. Y is dependent on x. Means y is some function of x. Okay. Now solution. First of all, I am writing the equation this given in the question paper. A d2 by dx2 plus dy dx plus cy equal to x. This is equation 1. Here A, B, C are constant. Here A, B and C are constant. Are constants. And x is the function of x. Function of x. We can say x is equal to some fx. Okay. Equation 1 can be solved with the help of following methods. We apply here following method. Apply the method of variation of parameter in equation 1. In equation 1, we apply here the method of variation of parameters. So here equation A1 is A d2 by dx2 plus B dy dx plus Cy equal to x. This equation 1. First of all, we find out the complementary function of 1. To find the complementary function CF, short form, we can say CF, complementary function of equation 1. If we want to find out the complementary function of 1, then putting right hand side equal to 0. Putting RHS 0. RHS is 0. RHS is x, so x equal to here taking 0. Then we get here. Then we get A d2 by dx2 plus B dy dx plus Cy equal to 0. This equation 2. Here right hand side is 0. If any equation of higher order with constant coefficient, right hand side is 0, then we find only complementary function of equation 2. Because in equation 2, right hand side is 0. Okay, we have taken here right hand side the function of x is 0. So in equation 2, we will find only complementary function. Equation 2 can be written as a y2 double dash, a by double dash plus b by dash plus cy equal to 0. This equation 3. This equation 2 can be written in the form y double dash means 2 times differential of y with respect to x, and y dash means 1 time differential of y with respect to x, and c by y is the function of x. Here y is the some function of x here. So let the complementary function of equation 2, we are considering here only. So now let us consider the complementary function of equation 2. First of all, here we are considering only. The complementary function of equation 2 is this. This is considering function. Okay. Y equal to a y1 plus b y2. This is CF of equation 2. In any complementary function, if two order of the differential equation, then there are two arbitrary constant and two solutions. So in complementary function 3, we see that A and B are arbitrary constant and y1 and y2 are the solution of equation 2. So y1 and y2 are solution of equation 2. Then y1, y2 is the function of x which is verified to equation 2. So the linear combination of arbitrary constant and y1 and y2 two functions, the linear combination is the complete CF of equation 2. So we considering y is equal to a y1 plus b y2 is equation 3. Now y1 and y2 are here function of x, solution of equation 2, where a and b are arbitrary constants. Solution y1 and y2 of equation 2 verify to equation 2. After verifying we get here. So putting in y1 in place of y in equation 2. Then we get here is y1 double dash y double dash a plus b y dash c y. This is equal to 0. This is equation 2. In y equal to putting y1, y equal to putting y1. Here y equal to putting y1. Then we get a y1 double dash plus b y1 dash plus c y1 equal to 0. This is equation 4. And y equal to putting y2. y2 is second solution of equation 2. Y equal to y1 is first solution of equation 2. So this solution verify to equation 2. So a y2 double dash plus b y2 dash plus c y2 equal to 0. This equation 5. Here y1 and y2 verify to equation 2. Verify to equation 2. 100% because these are the solutions of equation 2. So now let us consider complete solution of 1y. Complete solution. Now we want to consider the complete solution, not only complementary function. There is complementary function plus particular integral, both are combined here. So after putting a equal to u, and a is arbitrary constant, but here we are converting a as a u. A is equal to u is some function of x, and b is arbitrary constant, b equal to b is another function of x. In 3, putting in 3, a equal to u and b equal to b. After putting a equal to u and b equal to b, then we get complete solution of the equation 1, which is given in our question paper. So y equal to u by 1 plus by. Put in a equal to u here and b equal to v. Then we get solution this. This is complete solution 6, solution 6, and verify to equation this, because this is the solution of 1. Because this is the solution of 1. 6. Because 6 is the solution of 1. So where u and v are unknown function of x, and which we have to be find later. Now with the help of solution 3, verify equation 1. Solution 6, not 3. Solution, now with the help of solution 6, verify to 1. This is 6 solution. Okay. Differentiating 3 with respect to x on both sides. Differentiating 6 y dash. This 6 differentiating y dash. U constant differential of y1 y dash plus y1 constant differential of u dash plus b y2 dash plus y2 b dash. Okay. Now next y dash equal to u y1 dash plus b y2 dash plus y1 u dash plus y2 b dash. Here we are writing u dash b dash later. Y1 dash y2 dash write first and u dash and v dash write last. This equation 7. So that u b satisfy the following equation. Let y1 u dash plus this result putting 0. Later result, this last result we have taken 0. so that u and v satisfy the following equation, or putting y1 u dash plus y2 v dash, this equal to 0. Putting this result 0, equation 8. Putting in equation 7, this result is 0. This result putting 0, then we get y1 dash equal to u y1 dash plus b y2 dash, this 9. Again differentiating equation 9 with respect to x, then we get here y double dash u y1 double dash plus u dash y1 dash plus b y2 double dash plus b dash y2 dash. This equation 10. Substituting value of y and y dash, here again result, this result writing here y double dash equal to u y1 double dash and plus b y2 double dash and plus u dash y1 dash and plus b dash y2 dash. Okay, this equation 10. So this result taking equal to x. Here substituting value of y dash y1 y double dash in equation 1, then we get here. Now first half of result, this result must be 0. So here this is already 0. So putting here this result is 0. This result is 0 and this result already 0. Y equation this result. Y equation 4 and 5. We have this result is 0 and this result 0. So now we get this result. Equation 4 0 and equation 5 0 here. After putting this result must is x. Now this result is x, solving equation 8 and equation 13. Equation 8 this is and 13 is this. Solving 8 and 13 apply by cross formula. So after cross multiplication we get after cross multiplication here u dash upon this. So this minus sign, this minus equal to 0 and this equal to 0. So here multiply this minus bx minus y2x minus y2x and minus 0 equal to, this is b dash upon this minus here is minus sign, so minus this cancel, y1x minus y1x and minus 0, this equal to 1 upon here y1 y2 dash minus y1 dash y2. Okay, so now here u dash is equal to minus xy1 xy2 upon here y1 y2 dash minus y1 dash y2. V dash is equal to minus b dash is equal to minus plus y1 x upon y1 y2 dash minus y1 dash y2. So this is y1 b1 dash and this is u dash. This is the u dash and v dash. So now u dash means du over dx. U dash means here u dash means du over dx. Du over dx means here minus xy2 upon y1 y2 dash minus y2 y1 dash, y1 y2 dash, correct. So this is this. Then integrating on both sides, we get this formula, minus x y2 y1 y2 dash minus y2 y1 dash. See, and u equal to is this. We can find u this result. Now we have from equation 20 dv over dx. Here v dash is equal to minus x xy2 xy1 upon y1 y2 dash minus y2 y1 dash. Okay, this is v1 dash. v1 dash is dv over dx. This is dv over dx. Integrating on both sides, this result, we get this result. This is same as this. Now integrating, we get this b. And u, v are the solutions. So y equal to here u by 1 and plus b by 2. This is complete solution. This is complete solution of equation 1. Putting value of u and v. Putting of value of u and v. Okay. So now this is the complete procedure to apply the variation of parameter. In our complementary function, there are two arbitrary constant. Two arbitrary constant convert in two functions of x, u and v, and later we find out the value of u and v. And complete solution y equal to u by 1 plus b by 2. This is the complete solution of 1. So this procedure is known as a method of variation of parameter. Now, I want to discuss in steps the whole methods. What is the procedure to apply the method? Step 1. Finding complementary function of given problem. First of all, we find out the complementary function. Because our equation is second higher order differential equation with constant coefficient. In every constant coefficient, we find first of all complementary function. Anyway, we find out the complementary function of given higher order differential equation with constant coefficient. So here we consider a y1 plus b y2 is a complementary function of given question after putting RHS equal to 0. If RHS given in our question, then we are taking RHS equal to 0. Then we can find complementary function. Otherwise, we cannot find the complementary function. To find complementary function, RHS must be 0. RHS must be 0. So putting right hand side is function q. Q is some function of x. Q must be 0. In the given linear higher order differential equation with constant coefficient. So first of all, we find out the complementary function of given problem. Step 2, finding particular integral u by 1 plus v by 2. U and v, putting u in place of a and b in place of v. A and b are arbitrary constant. A, b are converting in some function of x. A converting in u is x, and v converting in b, considering b function of x. Then u by 1 and v by 2, this is the complete solution of equation 1. Here u and v are function of x. Step 3, find value of u and v with the help of the following formula. Here we apply direct this following formula. After this solution verified to equation 1, then we get this formula. This is general formula. U equal to minus x y2, y1 y2 dash minus y1 dash y2. V equal to x y1, y1 y2 dash minus y2 y1 dash dx. Okay. So u v we can find. Shortly we can apply this formula in our question. So here next I want to solve one question using the method of variation of parameter. This is very easy question. I am discussing this question in detail using the method of variation of parameter. And this is very most important question as very interesting method to apply in this question. Now solution. Solve d2y over dx2 plus y is equal to cosec x. This is equation 1. Okay. Equation 1 can be written as y double dash plus y equal to cosec x. This is equation 2. Now finding complementary function of equation 2, putting RHS is 0. Then we get here RHS 0 means y double dash plus y equal to 0. This equation 3. This is the differential equation of second order with constant coefficient. Then we can find CF of 3. CF means complementary function of equation 3. So now auxiliary equation of 3. Auxiliary equation of 3. 3 can be written as equation 3 can be written as d square plus 1 into y equal to 0. This is equation 4. Putting d equal to m and removing y from 4. Then we write here m square plus 1 equal to 0. This is equation 5. This is an auxiliary equation of 4. This is an auxiliary equation of 4. Now m square equal to minus 1, m square equal to minus 1, m square equal to I square, because I square is minus 1. So m square equal to plus minus I. M square equal to I square, m equal to plus minus I. So m equal to here 0 plus minus I. So now here m equal to alpha plus minus I beta. Now complementary function here. Formula for CF is CF equal to e to the power alpha x c1 cos beta x plus c2 sin beta x. plus C2 sin beta x plus C2 sin beta x. Beta x. So CF is equal to here alpha is 0 and beta is 1. So CF is equal to e to the power 0x in brackets C1 cos x plus C2 sin x. Now final CF is C1 cos x plus C2 sin x. This is complementary function equation 6. This is equation 6 complementary function. Here C1 and C2 are arbitrary constant. Okay. Equation 6 is the solution of equation 4 and verify to equation 4. Okay. Now finding complete solution of 1 by variation of parameters. Putting C1 constant equal to U and C2 constant equal to B. Then solution of 1 is y is equal to U y1 and plus B y2. This is equation 7 where y1 equal to cos x and y2 equal to sin x. Okay. y1 equal to cos x, verify to equation 4, and y1 equal to y2 equal to sin x, verify to equation 4 also. Okay. Now using formula to find u. So u is equal to minus x y2 upon y1 y2 double dash minus y1 double dash y2 and integrating with respect to x. This is formula for finding u, where y2 equal to sin x and y1 equal to cos x. Now here y1 y2 dash y1 dash differential of cos x dy dx of cos x. So this is minus sin x. y2 dash differential of sin x. So this is y2 dash is cos x. This is y2 dash. Putting this value and putting this value y1 dash. Y1 dash is this, y2 dash is this. All values putting here and x equal to cosec x. Here x equal to cosec x. All values putting here, then u is integration, minus sign is out, x is cosec x. What is y2? Y2 is into sin x and upon y1. Y1 is y1 cos x into y2 dash. Y2 dash into cos x. Minus sign y1 dash. Y1 dash is minus sin x and into y2. Y2 is into sin x and here dx. So this cancel to this and here u equal to integration minus, here is dx only upon cos square x plus sin square x. So now this equal to minus integration, this is 1 dx. Here cos square x plus sin square x, this equal to 1. So this equal to minus integration this x plus c1. This is u. This is equation number 9. We can find u with the help of given formulae which we are proved in the procedure of the applying method of variation parameter. Again we apply formula. Again we apply formula to find b. So here b is equal to integration x y1, here is plus and x, here is y1 upon y1 y2 y2 dash minus y2 y1 dash dx. This is formula for finding b. Here is some arbitrary constant plus c2. So now final answer here, putting all values here, u b is equal to integration x is cosec x and here is y1. Y1 is, what is y1? Y1 is cos x. Here is cos x dx upon. In denominator is same, cos x into cos x and minus sin x into sin x. Okay. So this equal to integration here. Here sin cos x upon sin x dx and upon cos square x plus sin square x. Here apply formula. Here apply formula. Cosec x equal to 1 upon sin x. Okay, this cosec x. Cosec x convert into 1 upon sin x. So this dx. Then b is equal to here cos x upon sin x and upon 1 dx. So integration of this sin x is t. Let here sin x equal to t. dy dx of sin x equal to dy dx of t. So here sin x cos x dx equal to dt. And sin x is t. So we get here t upon dt. So this equal to log t plus c2. So log of here sin x plus c2. This is value of v. Now this 9, this is 10 and here this formula we apply, this is 11 and this 12, this 13, this 14. Okay. Now putting result here, y equal to uy1 plus by2 is a complete solution of 1. Putting here u, y1, b and y2. U is, so here y is equal to this equation number u by 1. This equation number 7. This is equation number 7. Okay, this is 7. Putting yu is x plus c1. Y1 is cos x plus b is log sin x plus c2 and y2 is sin x. This is complete solution. This is u, this is y1, this is v, this is y1 by 2. So y is equal to x cos x plus sin x into log sin x and plus c1 cos x plus c2 sin x. This is CF and this is PI. This is PI. So final answer is y is equal to c1 cos x plus c2 sin x. This is complementary function plus x cos x and plus sin x log sin x. This is PI, particular integral. So now y is equal to CF plus PI is complete solution. Okay, here we applied variation of parameters. Okay, now the differential equation of higher order with constant coefficient is given in our question paper. And now we write this question as a equation 1. Then first of all we find out the complementary function. A differential equation given as a higher order with constant coefficient, then we can find easily complementary function. Okay, so putting right hand side equal to 0 in our given question, then then find out the complementary function. In complementary function there are two arbitrary constants c1 and c2 and there are two functions y1 and y2. So c1 y1 plus c2 y2 is a complementary function, which is the complete solution of a differential equation after putting RHS equal to 0. Now, next step we find out the complete solution of the equation 1, putting arbitrary constant as a function of x. So c1 taking as a u and c2 as a taking v, c1 and c2 convert in u and v both are function of x. Then our next solution is y equal to u y1 plus v y2. This is complete solution of given question. Okay, this solution y1 and y2 verify to equation second after putting RHS equal to 0, because y1 and y2 is the solution of those equations which we find out the complementary function. So y1 and y2 verify to equation, but y equal to u y1 plus b y2 verify to equation 1, because this is the complete solution of equation 1. After verifying, we get the value of u is equal to integration minus x y2 upon y1 y2 dash minus y2 y1 dash dx, And similarly, we can find the value of v is equal to integration plus xy1 upon xy2 dash minus y1 dash y2. So with the help of these two formulae, we can find the value of u and v. Then our and y1 and y2 we have find already. Then total solution of the differential equation is u by 1 plus v by 2. This is the complete solution with the help of variation of parameter. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.